This is a quick demonstration of my custom game engine named Worlds Engine. It's written in C++ with a managed C# scripting engine and focuses on fast iteration times. Let's get into it. This is one of my scenes used for testing the player rig. The editor has click to select, copy and paste, manipulation gizmos, and undo. You can also browse the hierarchy using the entity list on the left. In addition to that, there's a physics simulation, which allows you to settle physical objects within the scene. You can activate it for the entire scene, or as I'm going to do here, just for a subset of objects. The engine also supports playing the game directly within the editor, which allows you to drag out the scene view and use it as a quick picture-in-picture view for debugging things like procedural animation. In order to speed up iteration within the game, there's a custom C# hot loading layer which allows you to edit the code and instantly apply changes on the fly. Here I'm going to use it to tweak the control code for a drone as it's flying. If I spawn one in quickly here, you can see it hovers about. It uses PD controllers to apply forces directly up at the engines. There's no virtual hover force or anything. Every single motion you see here is direct just from the engines. This uses a system of PD controllers in order to control it. And this hot loading system was incredibly helpful in tweaking them to get them to the point where it can fly. Of course, I'm now going to use it to completely destroy the poor thing's ability to fly. And as you'll see, it'll wobble about more, and then go flying off. Poor thing. This hot loading also applies to assets. I can switch to Blender here and quickly edit the map. Not to do anything particularly useful here, but you'll see. There we go. A new giant concrete pillar. And aside from editing, the engine has numerous rendering features which I'm quite proud of. If I switch to perhaps a better looking scene here, it uses a forward plus renderer to render many real-time lights and has full support for PBR and IBL with reflection probes and box parallax projection. There is a bloom post-processing effect and a system that dynamically resizes shadow light maps for performance, which you can see here. The current resolution of the shadow map is printed there. The transition is designed to be visually seamless, so the only effect you notice is that it runs better. This all helps to achieve a high level of graphical fidelity while keeping to the strict performance requirements of VR, which the engine is designed around. I've now switched to VR to demonstrate the VR capabilities of the engine. Internally, this is rendering at a resolution of 2400 by 2700 at a frame rate of 120 frames per second on an RX 5700 XT. It's using OpenXR to communicate with SteamVR and the VR headset, which allows it to work seamlessly on Oculus, for instance, if you decide to switch to that. I'll also show you the game that I've been building atop the engine. It features a fully physics-based player rig, using rigid bodies for the hands, one for the head, one for the torso, one for the legs, and one for the feet. The entire body is held together using physics joints, which means that, for instance, if you are crushed by something from above, you will simply crouch down instead of fighting against it. The hands are driven by PD controllers, which move the hands entirely using forces, preventing strange penetration issues and other issues caused by moving objects non-physically. You can grab onto objects, which will essentially stick them to your hand using a physics joint, interact with them using the trigger, and put them in pockets around your body. Any object that can be grabbed onto can also be climbed. PD controllers feed the forces back into the body, which allows you to lift yourself with them, and hang on to the ceiling, for example. There are also guns, which fire using the trigger, and apply a physical recoil force to kick the gun back. This means that if you prop them up against an object, you'll see a slight reduction in recoil due to friction, for instance. Every projectile fired uses a real-time light, which you can see reflecting off of the environment around it. There's also a slow motion toggle using a timescale. Proceed onwards, we'll find a drone test subject ready to fire at. There's a telekinesis feature which allows you to grab objects, move them around, use rotation to rotate them, or just hold them in place relative to your hand. And you can launch them. You can also use the system to pick up objects from a distance by grabbing them and then pulling them towards you, which calculates a trajectory to launch them towards. Let's show off some proper combat. There is a slam, which knocks physics objects around you away, a dash, and a wall jump, which allows for plenty of movement. And of course, slow motion. You can grab onto enemies using the telekinesis, launch them into walls, damage them, or just dispatch them the standard way. That's a quick summary of the game that I've been developing, and an example of the combat. Thank you for watching.